Hi, Shafi. It has been a pleasure to share the duality journey with you. And it's great to have this opportunity to ask and discuss a few questions, which I am sure are of interest to many people. Can you tell us what piqued your interest in cryptography, data privacy, digital secrets as the key area of your research?
Rina, it's a pleasure to be here, even though we're in different countries, but it feels like we're in the same place. What has piqued my interest? So I've been working in cryptography for many years. Essentially, I was a graduate student at Berkeley in the early 80s, and that's when I chose my research area. And for many, many years, that has really stayed the focus of my research, even though I've done some other things, but cryptography has been sort of the central thread from the start. And I guess, so this is a little bit of a historical answer, but then it will take us to present day. So to begin with, I think that probably the first paper that I was presented to as something that might be interesting to read in order to think about research was by Dick Karp when I was a graduate student. And it was the paper by, I think it was a break of the Merkle and Hellman public key crypto system, which was based on knapsack. And at that time, I read it, but it didn't really, I wasn't sure what to do with it. And then the second thing, probably about 6 months or a year later, I took a class with Manuel Blum, who was my thesis advisor, on number theory. And it was all algorithmic number theory, how to come up with fast algorithms to solve problems in number theory. And at the end of the class, the last two lectures, he let us read Diffie and Hellman's paper on new directions in cryptography, and then the RSA paper, where they introduced the public key RSA crypto system. So one has to realize that at this point, these were the three papers. There was a Diffie and Hellman paper, there was RSA, there was this Merkle and Hellman, and there was the break of it. And that was it. And when Manuel gave us these papers, he also asked this question about, suppose you had Alice and Bob. There was always Alice and Bob, I think, were introduced in the RSA paper as a sender and receiver. And he was saying, let's say they're just two parties and they want to flip a coin. Let's say that each one wants to win some sort of bet. In his example, it was they had some custody of a dog or something, and they wanted to decide who gets the dog. And they were flipping a coin. And they don't trust each other, and they want the coin to be 50-50. Somehow that question really fascinated me, mostly because I love the number theory, which I think is why I got into it at that point and not in the first knapsack problem. So number theory is something that I naturally feel, both excited about and good at. And the idea that you can use a number theoretic question or sort of a number theoretic tools to emulate this real world question. Because what's the question here? You have a coin. Coin is something we all can think of. We don't need to be mathematicians for it, but we need to have also simultaneity with this flip, even though it's over the phone. So how can you somehow mimic or emulate this simultaneity using some features of number theory was very fascinating for me, and that kind of hooked me. And then from then on, there were these other problems that people have already looked at, which was like mental poker. There was this paper by Shamir Vesnadelman where they were showing how to emulate a deck of cards over the internet, and the idea of how you deal a card at random. And that was sort of the second thing to work at. But from there on, it became sort of much more abstract. So after solving those sort of concrete, nice puzzle-like riddles, like flipping a coin or playing a game, without a physical deck of cards, it seemed like we sort of realized that we discovered something deeper. So the first was sort of going away from an RSA type function to this idea that you would want to be able to encrypt a single bit. And if you want to encrypt a single bit, it was deviating from, rather than just taking a function that takes data and scrambles it, is try to think of a difficult question in mathematics, which is a yes/no question. And then you could sort of come up with instances of these questions. And if the answer was yes, you would be encrypting a 0. If the answer was no, you're encrypting a 1. And you'd be sending these puzzles over. And someone who had the secret key could solve the puzzle and know whether the answer was yes or no, and therefore know whether you meant to send a bit which was 0 or 1. And this was really a paradigm shift. It meant that you could encrypt hiding all partial information. And if we fast forward to where duality is today, where we use not just encryption, but we use homomorphic encryption. We really want a kind of encryption where you can represent zeros and ones, because those are sort of the basic atomic units that you compute on, let's say in digital circuits. And you would like to be able to manipulate, if you have two encryptions of zeros, or encryption of 0 and 1, or two encryptions of 1, to be able to do operations on them, and like ands and ors and nots, and come up with encryptions of the and of individual encrypted bits. So in a sense, those early works, which were in the early 80s, which is where my thesis was about, which was stimulated by these puzzles, brought on the idea of how to encrypt single bits, how to encrypt even many bits in a way that hides partial information, and how to do protocols, how to compute arbitrary functions, where the function is defined over, let's say, x1 and x2, where x1 is what Alice knows, x2 is what Bob knows. They want to be able to compute a function of that. For example, like whether x1 is equal to x2, whether it's different, whether x1 is bigger than x2, anything you want without revealing them. And all that needed to go more fundamentally to this question of how do you compute over inputs while hiding them, which requires, in some sense, representing the inputs as binary strings, encrypting single bits, and also encrypting in such a way that you can sort of manipulate the encryption. So it's a long-winded answer to a simple question. Over the years, this had opportunity to develop into lots and lots of interesting questions. Computing functions, on data without decrypting it. Computing functions among not just two people, but n people. Thinking that some of these people are your enemy. So it's not just somebody listening on the line, but it could be that actually the people you're working against, as in Alice and Bob flipping a coin, are not cooperative. Whereas in the original encryption, the sender and receiver, they want to communicate. It's just an adversary on the line. Then there were questions like signing contracts simultaneously. And these days we're talking about doing analytics on data while keeping it hidden. And there's so many questions that you can address, all of them using mathematics, not just number theory. At this point also geometry, logic, to emulate these scripts really, that you can just write, I want to do the following. It involves many parties, it involves privacy and utility. And how do you do it? How do you do it? Achieving privacy, utility, independence of inputs. So people can't choose their inputs after you've chosen your input. Simultaneity, and the list continues, and using mathematics.
This is really fascinating. And if we can fast forward to these days, now cryptography is becoming center stage in recent years. It is playing a key role in blockchains, Web3, cryptocurrency, buzzwords such as homomorphic encryption, multi-party computing, zero knowledge, public key cryptography are now being mentioned and explained to general audience. What is your perspective on this rise in public interest? Why is this becoming such a center of interest these days?
That's a good question, because as I mentioned, I've been in this field since the early 80s. And all these, many fabulous things were already true. You could do zero knowledge, you could do multi-party computation. These are not new possibilities. And yet I don't think anybody knew about it outside of, the students that I taught or my colleagues in conferences.
Like small group of people relatively.
Yeah, and now I meet like random people, seriously, and they ask me, so what is this zero knowledge about? How do you know about this? So it's become kind of a buzzword. Now they don't usually or necessarily know exactly what it means, but they've heard it. Now, where is this coming from? So first of all, I think the first thing was the rise of cloud computing. So rather than just talking about sending messages securely or doing electronic commerce, all of a sudden there was this idea of computing elsewhere, where our local devices are simple. They're really just sort of I/O or input/output, but you could do much more complex computing in the cloud. Second of all was the fact that data is so important. And I guess that's the rise of machine learning analytics. And that means also that we want to protect our data, but also that there is an advantage to be gained from data. So maybe that's the most important thing, that there's a lot that companies and banks and individuals stand to gain from access to data. So we see this in our everyday life when we drive. We want to know how to reroute traffic, energy use in the house, in the home, smart investing, and of course these days it also covers more sort of socially relevant issues like court cases and so forth based on data from the past. But really in the commercial sector, there's tons to be gained about understanding the market. And understanding the market means having access to data. But at the same time, people realize that giving all that data for free, first of all, means that you don't get utility out of it in terms of you're giving your data for free and you're not getting rewarded for it. And second of all, there's privacy concerns. Both governments have paid attention to it. Mostly in Europe, there's regulations, but also in California and elsewhere. And, even our experience online with all these, ads all the time and targeted advertising, and you can't even read anything anymore without being bombarded. You have to be very clever to know when to pay attention, not to pay attention, when real content comes up and when it's just advertising. So it's become very clear that this lack of privacy ruins our experience. We might not be able to get the data that we want because of regulation. And down the line, we don't know what the privacy loss means to us individually also. But my guess is fairly severe, especially in genetic type, who knows what predictions can come up from data that we've released in the past. So all this means that there's a lot more attention being paid to how can you get utility out of data while maintaining privacy, while making sure that, our regulations are being adhered to, so you don't have to pay penalty. And maybe most important, that maybe by maintaining privacy, you're going to be able to get a lot more data, and therefore utility will grow and your revenue will grow. So I think that that's the part that the market maybe doesn't fully understand yet. They do understand it in the cryptocurrency area. Mm-hmm. That's probably how, usually if you'd ask this question to someone else, they would say, well, the reason people understand cryptography now is because of cryptocurrency. I think that that's true to an extent, that was a new market, right? All of a sudden came out of nowhere, this idea that we can have cryptocurrency, the idea of distributed finance. And I think people don't understand fully yet that you can access more data. You'll be able to get a lot more out of data. If you obey you'll be able to have access to a lot more data, and therefore get much more refined analysis. If you don't require the data to be fully disclosed. Maybe in the medical area, that's kind of clear. Collaborations between hospitals, between clinics. Right now, you can't reveal patient data. You might not want to completely reveal what your statistics are when you're dealing with data of certain kinds. But on the other hand, if you had a way to reach the audience that you would be especially best serving, so particular kind of patients, then it could be a win-win. There'll be more clinics that would get more customers and serving them better. But all this requires access to a lot of data that you could not access today. If you had privacy and you could reach this data without compromising users' privacy and yet matching them, let's say, with the right clinics, I think the commercial value is huge. And I think Duality, coming back to us, because we're co-founders of Duality, has exactly that technology that enables you to do all this analytics, to do this matching, to do this benchmarking under encryption.
It also seems that more and more parties realize that there is a lot to gain by collaboration, and they want to do it now in a new way, not via intermediaries that actually aggregate so much data and they gain so much market power because of that. So it seems like there is definitely a very strong push to disintermediation, or a new role of intermediaries that can coordinate and orchestrate, but not necessarily gaining the knowledge of all the data in the network that they are coordinating.
Absolutely. So interestingly, now that you say it, if you think about the coin flip, also there, if you had a third party that flips the coin and you trust them, and then they tell you the outcome, but you don't trust, you wanted to do it without an intermediary. So that's really the crux of that first problem. And now, you know, we're involving more parties, and you want to do it more efficiently, then having some intermediary that facilitate this but does not learn anything about, which is what we're saying in duality. Yeah. We're there to serve it, but we're not going to learn anything.
Exactly.
We're just going to enable you all to get your data without learning about each other, except for what you're willing, and do it in an efficient manner. And cryptocurrencies and the whole blockchains, obviously, that's what it's about, right? It's doing away with the middleman, and having actually sort of a democratic
an ability to agree between parties without having somebody in the middle, or that somebody in the middle not gaining this huge power over everything.
That's right. That's right.
So, and cryptography obviously is becoming the one that kind of enables all that, and that's a kind of very powerful tool. And if you now look at Duality and the role of Duality as a company to make it all possible, to make it to the market, how is your take on that?
My take is that we have the technology, we have the know-how, we both the mathematically and the engineering. We have a platform where we can actually do this collaborative analytics. And I think that our challenge is not only to have the platform to facilitate what's done today, but to facilitate what's not done yet, and to show how this will increase revenue for those people who participate. But I believe that's totally the case, you know, in many different markets. So that's the challenge, and we have the know-how. So I think we're special in the way that we have the people who really are best suited to do this correctly, privately, and responsibly.
Great. So thank you very much for this discussion. I'm sure this will be of a lot of interest, and looking forward to the journey forward.
Me too. Thank you, Rina.
Thanks.